I am Dr. Obula Reddy. In this semester, we are going to discuss about the subject internal combustion engines and gas turbines. This is for third year, first semester, professional subject. First of all, before entering into this course, the students will require the minimum fundamental knowledge of engineering thermodynamics, which is already studied in a 2-1 semester, where the students will explore or become familiar about the first law of thermodynamics and second law of thermodynamics, the energy interaction, and all the required engineering thermodynamics. Core content is very, very important before entering into this subject, where the students can explore that heat interaction and the energy interaction of that particular internal combustion engine components. Now, before entering into that main content of the course, at the end of the course, the students should be able to achieve the following 6 outcomes of the course. At the end of the course, the students will be able to, first one, understand why thermal efficiency of actual cycle is lesser than the ideal cycles. Normally, the real-time cycles, whatever that internal combustion, like bike, car, or maybe that lorry, bus, if you are going to take any internal combustion like automobile engines, those are all called as actual cycles. Its efficiency, thermal efficiency, is lesser than the ideal cycle. Ideal cycles are the air standard cycles. Here, air standard cycles, the working medium is air. But whereas in the actual cycle says this is air fuel mixture, original, how the petrol, diesel and will combust with the help of air, that is what the air fuel mixture, but whereas here air standard cycles. Okay. Now, normally, the students should understand what is the reason behind why thermal efficiency of actual cycles is less than the air standard cycles. That the first thing should understand from the unit 1. Coming to the second course outcome, understand working of IC engine and its components. Normally, the students should be able to understand the clear-cut various components which are involved in the internal combustion engines, like the engine head, valves, mechanism, and connecting rod, all those things, piston and cylinder movements, and various strokes involved, ports, fuel injection pump, cooling jacket, and all those things should understand and how it's working also. Normally, the basic working of internal combustion engine should understand from the unit 1. Third one is select fuel of an IC engine and its importance can be known. From third unit, students should be able to gain the requirement of a specific fuel for a particular engine. That part students should be able to explore, because where third unit we are going to deal with SI engine combustion. This is SI engine combustion. We are going to deal with SI engine combustion. And the fourth unit is select a fuel for CI engine and its importance, like a compressed ignition engine. This is CI engine. This is CI engine combustion. Here, students will be able to explore the possibility of the fuel for diesel engine. Like nowadays, we can see that there are some alternative fuels are coming up in the industry. Like ethanol and its combinations, various alternative fuels. That part also can be explored in from the fourth unit. And the last one is last but one, draw the performance curves of an internal combustion engine and heat balance sheet. This is the most important for understanding the real-time working condition of an internal combustion engines. Say, for example, if you are going to look at into the original working or the actual working of internal combustion engines, you might have experienced in the real time also. When one person is driving a vehicle, say for example bike, what is the mileage and the pickup and corresponding the fuel consumption, if you are monitoring. The same thing if you are going to add up 1 or 2 more persons, etc. In the first case, one person is driving at 60 km/h, and the second case, if you are going to drive 2 persons at the same speed, then you can vary that fuel consumption. And also the corresponding pickup and mileage and all those things will vary. That is what we need to explore in the unit number 5 of internal combustion engine. And next one is the heat balance sheet. From the heat balance sheet means that IC engine is a heat engine. For that heat engine, we are supplying a few amount of fuel. That is chemical energy. Now the chemical energy, after combustion we are going to get heat energy. That heat energy is converted into mechanical work, some part, and something is lost to the atmosphere from the engine cooling aspect and all those things. Now we have to make it balance, how much we are giving fuel to the engine, how much it is converted into useful work like brake power, and the remaining how much is that means converted into waste energy like heat losses and all those things, frictional losses. Everything we need to count under this heat balance sheet. This is the most important concept to understand the losses and the efficiency of the heat engine. And the last one is evaluate the performance of the gas turbine. These are the gas turbines. Another one is last experiment is the last unit is the gas turbine, where students will explore different types of gas turbines, open cycle and closed cycle gas turbines, and it's working like a Brayton cycle. And if is there any methods like to increase the efficiency of the gas turbine, all those things can be discussed in the gas turbine. Then coming to the next slide. Now here we are going to give brief overview of the entire syllabus from each unit. Okay, total we have 5 units of syllabus, total 5 units. In the total 5 units, total we have 5 units syllabus. In the unit 1, the first unit, review of ideal cycles. Or ideal cycles means air standard cycles. This you must understand, which is already studied in the second year thermodynamics. Air standard cycles. Next one is comparison of air standard, fuel air and actual cycles. Once if you are recalling after brief overview of the ideal cycles like Otto cycle, diesel cycle and dual cycle, after a brief overview of these cycles, then we are coming into that second part, comparison of air standard cycles with fuel air cycles. Air standard cycles with the fuel air and actual cycles. In the air standard cycles, air is the working medium. In the fuel air cycles, fuel air is the working medium, and actual cycles also, fuel air is the working medium. But what is the difference is, here all the processes are in the air standard cycle, all the processes are the reversible process. But whereas coming to fuel air cycles, here the processes are reversible, but whereas in the actual cycle, the processes are the irreversible. That means here in the air standard cycle, everything is ideal. Ideal working fluid air and ideal process means reversible process. But whereas coming to fuel air cycles, we are having actual air fuel mixture. That means the real time working fluid inside air fuel combustion. But the process like section, compression, expansion, exhaust, that to complete a cycle, we are going to have total 4 processes will be there. All that process will be the reversible process. That is one aspect in the fuel air cycles. And the second one is the actual cycles. In the actual cycle, what is the exact thing is, we are going to take a real-time working fluid air fuel mixture and a real-time process, reversible process, irreversible process. Okay, that is what. Next, actual and fuel air cycles of the IC engines. This is the same thing. Actual and fuel air cycles of the IC engine. Here also we can get into that CA engines. Okay, actual and fuel air cycles of the CA engines, where we can understand that actual working process of the CA engine and the fuel air cycles of that CA engine. We can make a comparison difference, exact difference. We can understand from unit 1 clearly various cycles and its their assumptions, and that comparison we must understand from the unit 1. Next, here one diagram is there. This diagram is a very important diagram where you can understand students clearly. Suppose if you are going to, this is the actual cycle diagram. This is actual cycle diagram. This is actual cycle diagram. Okay, normally if you are going to take ideal cycle, Otto cycle diagram, it should be like this. It is like this. Ideal cycles, Otto cycles. This is P and this is V. This is simple Otto cycle. Okay. In this Otto cycle, 1 here, this is 2 and this is 3 and this is 4. 1, 2, 3, 4. But whereas here, see, various curves are there, but whereas here sharp corners are there, because this is ideal, no losses associated. But whereas in here in this diagram, various losses are there in actual conditions. So that is why that higher pressure and that dashed line is there. See that dashed line. This dashed line is nothing but ideal cycle. This dashed line is nothing but this is ideal cycle. This one. But whereas that another continuous line is nothing but actual cycle. That is what the difference. Now unit 2. In the unit 2, students will able to explore the engine, combustion engines working and its classifications. So the first one is engines means IC engines, internal combustion engines. Classification. IC engines can be classified broadly into petrol engines and diesel engines, and also it's also called as SA engines, spark ignition engines, and CA engine, compressed ignition engines. Then another one is based on the number of cylinders, single cylinder engine, multi-cylinder engine, and also based on the strokes, 2-stroke engine and 4-stroke engine, based on the arrangement of the cylinders like V cylinder engine or inline cylinder engines, opposite cylinder engines. Like that, there are different classifications of that IC engines are there. That part we can see. Next one is the working principle. This is most important. Working principle of internal combustion engine is very simple. It is working based on simple 4 strokes, like section stroke will be there, compression stroke, expansion stroke, and next one, last one is the exhaust stroke. These 4 strokes, like to complete the cycle to 4 stroke, here the piston is moving up and down. The piston is moving up and down, like it is undergoing 4 strokes. During that 4 stroke, what is happening to this valve section? Okay, what is happening these 2 valves, when that valves are opening and when that valves are closing? During opening and closing, what is happening to the real-time working mixture? That is part we need to understand. That is what the working principle concept. Coming to valve and port timing diagram, where in the same way here this is the valve. Okay, these are the valves. Now whatever this is there in the valve stream, next these 2 are the valves, this one and this one are the valves. Now these 2 valves, one is intake valve or inlet valve, another one is exhaust valve or like outlet valve. These 2 valves, based on the piston movement, when it will open and when it will close, like if you are going to represent on a diagram, like some circular diagram. Okay, this is the TDC and next this is the BDC, bottom dead center. If you are going to draw, suppose if you draw it, yeah. Okay, this is the actual diagram. Okay, you have to represent like inlet valve open somewhere from this point, some angle we need to represent. This is exhaust valve close and this is the exhaust valve open, and this is the inlet valve open. This is inlet valve close and this is the inlet valve open. All those things we need to represent. That is what the valve timing diagram. Port timing diagram is for the case where instead of valves, some ports are there. But the same story will be applicable for there also. How the valves are opening and closing with reference to piston position. In the same manner, we have to see that how the ports are opening and closing with reference to piston position. That is what the port timing diagram. And the next one is fuel supply systems in SA engine and CA engine, like carburetors, next port fuel injection and direct injection. This part will be discussed in the second unit. Fuel supply systems, like in SA engine, how we are supplying the fuel, what is the importance of the carburetor. Carburetors are mainly used in the petrol engines, where we need to mix the air fuel thoroughly before entering into the combustion chamber. Okay, that is what the help of carburetors. And also one more thing is there, port fuel injection and direct injection. Suppose if you are injecting the fuel in the inlet manifold, not in the combustion chamber, that means this is the combustion chamber. This red portion is the combustion chamber. You are not injecting the fuel into this combustion chamber. You are injecting into this port. And that means inlet valve. Then that is nothing but port fuel injection. If you are injecting the fuel into direct in the combustion chamber, it is called as direct injection. That is what this difference. Next, ignition, lubrication and cooling systems. I think you are aware of that significance or the importance of this ignition and lubrication and cooling system for any internal combustion engine. Normally, lubrication will be provided to avoid any friction between the 2 rotating parts, or where the contact is their movement, where we are going to provide the lubrication to reduce the frictional losses. And also cooling systems. What is the importance of cooling system? Cooling systems will be provided to reduce, that means the higher temperature of that engine, so that to maintain a required temperature of the engine, to safeguard the engine to overheat. Okay, that is why we are providing the cooling systems. Cooling systems, some classification are there. Air cooling system is there, water cooling system is there, some another additional coolants will be there for providing efficient cooling systems. These are highly used for achieving the better performance of the engine. Next one is unit 3. Under unit 3, we are going to see it in the first unit 3. We have two parts. One is combustion SI engine. Combustion in SI engine, like a normal combustion will be there and abnormal combustion. Suppose in the normal combustion, without any presence of knocking and detonation, it's like some regression will be there. One side combustion will start it slowly moving and the last end of the air fuel mixture slowly. That is what normal combustion. But whereas in the abnormal combustion means once if the combustion starts at this position, then instead of it is slowly moving in this regression way, all of a sudden in midway within the fuel mixture, somewhere combustion will start. Due to that, the portion of high temperature points, somewhere because of that carbon deposition and all those things, then all of suddenly somewhere itself combustion will start. Then these two combustion waves will collide and we are going to get some sound. That is what knocking. Okay, that means it is not common. It is abnormal. That is what abnormal combustion. But effect of engine variables. Another thing is effect of engine variables, like a pre-ignition and knocking, all these things, fuel requirements, rating and anti-knock additive. Suppose what are the requirements of the fuel to avoid this type of anti-knocks, how we are going to avoid this pre-ignition part. That is what I told, pre-ignition and knocking. How can we avoid? Is there any requirement which is like octane number is there and cetane number is there? These are the very specific things to identify that the fuel is better suitable for that combustion chamber, like AC engine. Next, combustion chamber and requirements and types. Some designs will be there, like these here. Suppose you can modify that the combustion chamber shape and size and everything. Okay, and these are the parts where we are going to discuss in the unit 3. Unit 3, another part is there. This is the combustion in CI engine. CI engine means compressed ignition engines, where we have compressed ignition means fuel injector will be there, where we have a fuel injector. Suppose if you are seeing in the graph also, this one we have stage 1. This is the start of combustion. This is the compression pressure, like injection will be there, fuel injection will be there. These are the curve, like time degrees for the crankshaft rotation. On the y-axis we have the pressure, on the x-axis we have crankshaft rotation. Like if you are going to see that the section, compression, next expansion and exhaust, these 4 strokes, if you are going to represent on an angle, the particular movement, if you are going to monitor when the fuel injection will start, and okay, 1, 2, 3, 4 process are there. 1, 2, 3, 4. This is the region. What is happening exactly during the combustion? That part we can explore in the combustion in CI engine part. Like it's a delay period. It is one first delay period and its importance, the effect of engine variables and diesel knock, section, compression, combustion induced turbulence, open and divided combustion chambers, fuel requirement, fuel rating. Here also the same story. How the SI engine we are going to discuss, same thing here we are going to discuss, but here the add-on part is we need to remember that instead of spark plug, here we have a fuel injection pump. That is why we are going to talking about the delay period. Next one is unit 4. Under unit 4, we are going to establish various performance parameters, like how we are going to monitor that IC engine performance. This is the just spring loaded dead weight measuring. Next, testing under performance parameters, parameters of performance, measurement of cylinder pressure, fuel consumption, air intake, exhaust gas. Next, brake power and Morse test. These are all the various tests we need to perform. Like we have parallelly thermal engineering laboratory is there, where students can perform various experiments of and all those things, and parallelly they will calculate brake power, more like indicator power, frictional power will be there, after mechanical efficiency, brake thermal efficiency, indicator thermal efficiency, volumetric efficiency, air fuel ratio. These are all the various parameters, and specific fuel consumption will be there. These are all the various performance parameters where students can clearly understand the real-time performance of internal combustion engine, how it is being subjected to the load on the engine, because performance will be vary depending upon the load on the engines. That is most important to explore or to sync with the real-time conditions. And last, unit 5. Under Unit 5, we are going to discuss about the gas turbines, like simple gas turbine plant and ideal cycle and essential components and regeneration. These are the methods: regeneration, intercooling, and reheating. These are all the various methods for increasing the efficiency of gas turbine cycles. Okay. Next, brief concepts about compressors, combustion chambers, turbines, and gas plants. Like these are the components, like devices. Okay. This is the overall syllabus of that total internal combustion engine. Next, if you are going to enter into next slide, heat engine. Normally, what is meant by heat engine? Suppose you studied even in the first year thermodynamics, like a second year 2-1 thermodynamics. A heat engine is a device which transforms our chemical energy of a fuel into the thermal energy and uses this energy to produce mechanical work. Here, if you are seeing three energies are there. First one, we are giving that chemical energy, means in the form of fuel like petrol or diesel. There is a chemical energy giving to some device. Okay, suppose if you are going to consider a device, this is the device, or heat engine. This is the heat engine. For this heat engine, you are giving input, you are getting some output, like certain losses. This is the normal story. Now, what is this heat engine? Heat engine is a device which converts or transforms one form of energy to the another form. This is one form of energy, chemical energy. Here is mechanical work. Okay, some losses, heat losses. Like there are various factors are there. Now, if you are going to, it is classified into two types: internal combustion engines, like external combustion engines. External combustion engine, we can see like somewhere combustion will takes place. There, with the help of that, we are going to produce some steam. That steam can be used as a working medium in the operations. That is external combustion engine. Combustion is taking place like in some environment where we are developing another working medium, like steam engines. In the steam engines, initially we need to develop the steam. That steam may be generated using that external combustion engines. But whereas coming to internal combustion engine, combustion is taking place in a closed region where, like so this is what the heat engine. Okay, where closed region, like in the case of piston cylinder arrangement, if you are going to see, this is the piston, this is the combustion zone, this is the just combustion zone. Next, heat engine. This is the schematic diagram of heat engine. For this heat engine, you are giving certain heat input, like heat energy, but it is converting output as a mechanical work. And the last one is output. This is the loss. These are all the losses, heat losses. Here, see, they have mentioned output. This is the output. Actually, this is correct. Mechanical work you are getting, and this is the losses. Output is the losses. Like this is the heat engine. Here, you can imagine anything. Even our human body also can be applicable here. We are taking some food as an input. Okay, we are taking some food as an input, and we are all doing some physical activities. And finally, some wastage is taken place. Okay. Some wastage is taken place. Maybe in the morning, we are normally going for even that washrooms, and some wastage is taking place. Okay, here, simple logic is we need to understand heat engine is nothing but some device which converts one form of energy to the another form with certain losses. That's it only. Now, internal combustion engines, can you guess what it is? Internal combustion engines, can you guess what it is? Normal internal combustion is nothing but a heat engine. Nothing is there, which is converts one from chemical energy to the mechanical work. Very simple. Now, the IC engine relation with engineering. How the internal combustion engine is normally related with the engineering. The engine is the ideal teaching tool. It features all of the elements of the engineering: materials, fluids, thermodynamics, lubrication, chemistry, electrodes, electronics, etc. The only thing missing is here nuclear reaction. Suppose if you are going to deal about the internal combustion engine, there are a lot of engineering subjects are involved, like materials is involved, like where the materials subject is involved. Fluid mechanics will be involved, like a flow of fuel, coolant and lubricant. Fluid is involved. Thermodynamics, like heat energy interaction, will be involved. Lubrication, we are going to provide the lubrication for supporting that to avoid the frictional losses. Next, chemistry. Combustion is nothing but a chemistry. Electronics, we are going to use some sensors. Like the IC engine is consists of many subjects. It is not a single consist of only single subject. It is composed of all relevant like different subjects, like electronics electronics will be there, materials will be there, fluid mechanics will be there, thermodynamics will be there, even something like chemistry, combustion will be there, some lubrications will be there. These are all various different subjects come together and forming a internal combustion engines. Okay. What is combustion normally? How we are going to define combustion? Combustion is very simple. In single statement, we can say that it's a rapid chemical reaction. Combustion is nothing but a rapid chemical reaction. Here in the last, if you are going to see a substance, this is the fuel, let us in our understanding, and this is the oxygen means air. Here we are getting, okay, and some work, like here we are getting heat, some plus some light, of course. Okay. This is the, when hydrocarbon fuels burn, they react with oxygen and releases heat and light energy. This is an oxidation reaction called combustion. This is oxidation reaction combustion. We can say that simply combustion is a rapid chemical reaction. If you are seeing that last, that triangle, one side is oxygen is required, another side is fuel is required. If these two interact and form a combustion, then we are going to get heat. Next, what is heat engine? Heat engine, that's what we have seen earlier. Okay, here you can clearly understand how this heat engine is working. An engine is a machine which is with moving parts that converts power and energy into motion, another form of energy. Here we can simply understand that how the movement we are going to generate with the normal components. Just you take some container is filled with water. Okay, like this is the external combustion engine. Somewhere you are going to generate the combustion. With the combustion heat, you are using that converting water into steam. That steam pushes the piston. Here inside piston is there. That this is the piston inside. Piston is moving reciprocator up and down. As it is moving here, this connecting system, this connecting mechanism will rotate this wheel. This is how normal heat engine. Finally, you are converting this heat into this rotational energy. That is what very simple heat engine. You are converting that heat energy into mechanical work. Engine is a machine which converts heat energy, fuel into mechanical work. That's simple. These are all the various applications of internal combustion engines, like in the automobiles we are going to see in many, like even in the aerospace industry, like jet engines, or we have aviation industries like aeroplanes and all those things. Even gas turbines, these are the ships to maintain that the huge requirement of input power, some HP, like huge amount of those things. We are going to use this internal combustion engine for these marine applications, like for garden applications or agriculture and train, and this is a tractor for IC engines, even for agriculture field, and these are the aeroplanes. Okay, different. Normally, these are the animation how that a car engine works. Car engine means very simple. IC engine works. How an IC engine works. Here we have total 4 strokes will be there. This is one 4-stroke. Now I will explain one by one. See, first one, intake, compression, combustion, exhaust. Intake, you can see that 1, 2, 3, 4 is there. Intake stroke, we are taking the fuel inside. Okay, if it is the CA engine, air will come inside. Next 2, you are compressing the that means air fuel mixture or air. Okay, after third stroke is power strokes. Once combustion takes in place, piston will pushes downward direction. Fourth is we are exhausting that air fuel mixture outside. Again the cycle will begin. Okay, again the cycle comes down. This is the very simple. Like this is nothing but internal combustion engine working. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.